All right, so we are back at this project, and I'm really excited. Things worked out as expected. So remember, in the morning stream in part 3 of this project, I um wrote. I struggled with this a little bit, but I figured out like this save function actually goes in after this. So this will be executed, like the model will be saved after it has been fit, so but anyway, I figured that out after the fact, and I think this saved successfully. Fruits.h5 is right there. So today's project is going to focus on a couple of things. So this callback function that I implemented earlier works, and we know that it works because when the training reached 98% accuracy on the validation data, it's terminated. It gave us a message, reach desired validation accuracy, so canceling training, and then the model was saved. So just to make sure the model was saved, I'm going to run this cell. Oh yeah, so this is like the accuracy scores. So this was run successfully. So one thing we can do right here is so I have a couple of objectives to this. So try to import the model that is saved to make sure it was actually saved. And then I want to graph the loss function and the accuracy scores, and then use the model to do prediction on a test image to see how the model performs. So those are my objectives for today. Once I accomplish these things, I'm gonna go to bed. So right now it's actually 8:34 p.m. where I'm at. So I'm going to work on this until about 10:11 p.m. And at 10:11 p.m., if things are not working out like I expect, then I'm going to go to bed. But hopefully by 11 p.m. I'll be able to figure stuff out. So let's get coding. All right. So let's see. How do we Keras? Uh, yeah. Let's just go to the Keras documentation. So let's go. This will be under model, I believe. Um, I'm trying to find the documentation on saving the models. Okay. Load model, something like that. Okay. So this is the code syntax to load a model. So I'm going to copy this, and hopefully this works. So right here it says file path, or one of the following says h5 object, a string of path to the saved model. Okay. All right. So compile. The default is true. Custom object equal to none. All right. Let's see if this code is going to work. All right. So I'm going to do two things. So this right here is loading saved model for verification. Loading using two methods. One is one is using h5 file, the one that says this one that says fruit.h5, and loading using file path. All right, so this one right here is loading using, let's just start by loading using .h5 file and see what happens. So let's call this new fruit model is equal to that. Okay, and instead of file path, I'll call this fruit.h5. all right, so let's go ahead and run this cell and yeah, see what happens. If it throws an error, we'll try to fix it. That's what we do as programmers. We break things and we fix things. Name fruit is not defined. All right, so okay, so all right, let's go back to documentation real quick. Used in this guy save and let's look at this and see how they used it. All right, callback fit the model. Okay, so this is loading the weights, but I want to load the whole model. Okay, saving the entire model. Okay, model that fit. New model equal to TensorFlow.Keras.models.load model. Is that what I have? Keras.models.load model. Okay. Oh, and this is in quotation mark. Okay, that makes sense. This is entered in as a string. Let's try that. It works. Okay, let's see. Warning, TensorFlow, blah, blah, blah. From TensorFlow.python with this type is depreciated and will be removed in a future version. What do you mean? Instruction for that to call initializer instance with the D type argument instead of passing it to the constructor. Like, I'm just gonna ignore that for right now because I have no clue what it means. But let's verify that this new model, like this is actually loaded correctly. So let's do new fruit. A new fruit model dot history. I assume that the answer to this will be similar to the answer to this if it's actually the exact same model, you know? Let's run this and see what happens. So sequential object has no, okay. Sequential object. Let's go back to the documentation. Excuse me. Okay. Oh, so for us to get the loss and the accuracy, we have to do evaluate these test images, test labels, print restored model accuracy dot format 100 times accuracy. Okay. Okay, this is loading a new model. Okay, so let's check the architecture of this new model. So new model. All right. Dot summary. Right. Oh yes. So okay. So our new model works. So this model that we did right here, successfully was successfully saved. As you can see, its summary is exactly like the summary of um the one earlier. So this is the summary of the original model, and this is the summary of the new model that was saved. So this is good. This is good verification that the model was saved correctly. Okay. So in order for us to use this new history, if in order for us to use dot history accuracy, we first have to evaluate an image object using this fruit model. So this code doesn't work, right? Let me put a note here. In order to use this model, comma, we first, excuse me, have to evaluate an image using the model. For example, I'm going to put an example here so I remember. I'm going to put this in here. I like to put a lot of notes in my code so I remember what I'm supposed to be doing. So if we go back up here. Okay, yeah. So this is what the code is supposed to look like. Okay. Do above code before doing below code when new model is loaded. So this way I know why this didn't work in the first place. All right. So now I have just verified that the model was accurately saved to this fruit.h5 package. Okay, and now I want to see. So if we go back here to where is this? If we go back to saved model, saved model.bb, right? I want to make sure that this is correctly saved, right? Variables. I don't know what these things mean. Where I think this is like what I need right here. So I'm going to copy the file path to it. And then let's go back here. Let's see model directory is equal to this. Actually, this is the model directory. And now let's repeat this code here. Let's repeat this code. This is just to verify that the model was saved correctly. So I saved the model in two formats. I saved it using .h5, then I also saved it using .bb format. So I've verified that the model was correctly saved in fruit.h5 model. Now I'm just correctly verifying that the model was also saved and this saved model PB thing. So yeah. Okay. Yeah, I'm guessing excuse me. Let's call this v2. Okay, let's go ahead and run this and see if it throws an error or gives us what we want. Ooh, big error message. All right. Okay. Saved model file does not exist. Huh. Okay. Maybe this is not. Maybe we do not go all the way to the end. Let's try this again. Why scanning string literal? Huh. How about that? It works. Oh yes. Okay. So basically, the directory that you point this to is the directory containing the saved file and not the file itself. So there are two ways to save this. So if you used this format, your result goes in here fruit.h5. But if you use this saving format, then you create a folder that has the file inside it. So let's try. Actually, you know what? Let's try this again. I mean, I know it's not gonna work, but I like to just make sure of something. This is probably not going to work, but hey, you never know until you try it, right? This should not work. Yeah, because we haven't run things through it. We haven't done an evaluation using this, but this should work. We should get a similar and is the exact same summary when we do this. When we run this line of code right here. Yep. So the model was successfully saved in two different formats. So yeah, even though I struggle with this a little bit in the morning, I eventually figure. Even though I struggle with how to save this in the morning, I eventually figured it out. So this is really good because this means that next time when I use this model, when I use when next time when I want to use this model, I don't have to train all over again. The model is saved with the weights and everything, right? That's what it says right here. So this one saves the weight, the configuration, the optimizer configuration. Okay, yeah. So we need to evaluate. So my next step is I'm going to graph the. Okay, I want to check something real quick. I'll do at the top. There are different ways to save TensorFlow models depending on API you're using. So okay, so you could also save with Acre. Okay. All right. So let me see here. So I could share this model with other people who can recreate the work. The code to create the code and the drum. Okay, so with this I could, okay, so this makes sense. I could share my model with other people by saving it. Okay. And so they do dot fit, right? Checkpoint dot format. Where did this checkpoint come from? File path equal to checkpoint. Okay, checkpoint is this. Oh, so this is basically a callback that saves the model's weight every 5 epochs. And then you can train the model with the new callback. I see. Okay, so this is one way to implement saving the model too. So this is like a third way. So I'm going to copy the link to this website and just paste it here for my own. Another way to save a model, right? Okay. Now let's get back to what we are doing today. So we've done that. So graph the loss function and accuracy scores. That's what I'm going to do next. So for me to graph the loss function and accuracy scores, let's go here and this is graphing loss function and accuracy scores of the model I just built. The model, the fruits model, right? Alright, I already imported matplotlib as pyplot. I think so. I believe so. I believe matplotlib has been imported. Yes, because I'm going to need that. So ACC is equal to fruit model dot history. Okay, that's what I called it, right? Fruit model. Fruit model. Okay. Just have to verify. So this is basically, so this accuracy that I printed out here, the accuracy scores. So this is the accuracy scores for the training data set. So these accuracy scores that I printed right here is basically the exact same things here. So it's being stored in this ACC. And then let's get the accuracy score of the validation accuracy. So basically we are going to be comparing the accuracy score of the training data set and the validation data set. And to get access to the validation accuracy, you do val accuracy. All right, and then the loss is equal to fruits model dot history, and in this case I want loss, and then same thing again, the validation loss is equal to fruit model dot history dot val. loss. All right. So we've defined the accuracy scores and the loss scores from the model. Now we are going to define the epochs, or should I say the x-axis is equal to the range. So the x-axis is just going to be the length of accuracy. That's just what the x-axis is going to be. So this here is x-axis, and this is accuracy score from the model that has been trained. So training, and I like to comment code, and this is validation. And this is for validation. And now let's get on to the graphing part. So plt.plot, we want to plot to the x-axis, which is epochs, and then the y-axis is ACC, and then we give it blue and round, and then we'll label this training accuracy, right? And then we'll repeat this process again. This one is validation accuracy. We want them to be on the same graph, and we want this to just be kind of like a blue line. Label validation, and then we'll give it a title. We'll call it training and validation accuracy scores. All right. Basically, doing this shows the graph, and then we'll repeat something similar. We'll just do basically repeating this all over again. And in this case, epochs, but instead of accuracy, we'll do loss, and I kind of want this to be red. Training loss, validation loss, and I want this to be red, and this will be my validation loss, right? Okay, and then training and validation loss scores, and plt.legend basically makes sure that all these labels show up, and then finally we'll do plt.show. Let's run this code cell and then see what happens. Ooh, fancy. I like it. So let's go and save this. So if my computer crashes again, we won't lose everything. Oh man, last night was really sad. Okay. So actually I want to show this one too. Like, why is this not showing? There we go. That's why so we have the training accuracy, right? And then we have the validation accuracy, and then we have the training loss and the validation loss. So you could see that, oh, that's a sharp drop. So you can kind of see the relationship between the validation accuracy and the training accuracy. So this right here just shows us that in the accuracy that it's not overfitting or underfitting, because we want the validation accuracy to be close to the training accuracy. The validation accuracy being close to the training accuracy is basically an indication that our model trained very well on our model after training on the training data set is able to adapt well and recognize images from the validation data set. So we want these numbers to be close. So this is good. So basically we've completed the second objective of today's coding. And last but not least, the the moment of truth, right? So now the objective is to use the model to do predictions on a test image to see how it performs. Ooh, this part is scary. But this is the moment I've been waiting for. Seriously. All right, so let's see here. Let's go back to TensorFlow documentation and see how to do predict stuff. I keep going back to the TensorFlow documentation because I don't have it. I don't have this whole syntax memorized. All right, so we got TensorFlow. No, not this. TensorFlow.Keras, and I want to go to, I think it's the models.predict. Okay, no. Let's go to model right here. And let's scroll down and say model.predict. I was looking at this earlier. I just don't remember where I saw it. Model.compile, evaluate, so when you use model.evaluate, I'm going to use model.evaluate. So what is the difference between model.evaluate and model.predict? So it returns the loss. So model.evaluate just returns the loss and accuracy metrics for the model in test mode. Okay. And X is a data set. Alright. I kind of want to try this. But first of all, let's do model.predict, because I don't know how long this model.predict is going to work. I mean, I don't know how long it's going to take it to do the prediction, so I kind of want to get that done before I start playing around with this. So feed generator, oh, it's right here. I didn't know they had like content table on the right side. Now I know. So model.predict, let's see. X is a TensorFlow.data set. Okay. Okay, so a numpy array. So a data set. So by data set, does it mean like so if I'm feeding a data set into this, what kind of does that mean I'm using me see if I can find load images. Not this. Let's go back one more. Let's look at something else. So let's go back to use in this tutorial. Load a pandas data frame, save and load models. Actually, I think this might help. I think isn't this the link where I just came from? It is the link. So let me see. I think they use model.predict here. Can I search this page? Control F, right? Searches the page. Let's search for predict. New model.predict test images dot shape. Test images. What does test images represent? Where did they define test images? Let's find out. Surely test images were defined somewhere. Oh, okay, there we go. Test image. Okay. Okay, so this makes sense. I have to load the test images, and I have to but I only want the actually I'm only going to load the first the test images. Because the structure of our data set is we have the fruit split, and then we have test, and inside test we have 15 different categories. So we have 15 different categories. Okay, so what do I define as my test images? Do I define the individual? So it's like I only want to load, let's say if I want to go to Apple, for example, I only want to load the first two apples. I only want to load like one apple from this, and then load one banana from this, stuff like that. So I need to define my test images. Okay, let's see what this guide is showing us. Let's see here. Oh, they're using the eminence data set again. Not very helpful. Okay, let's go back here and let's start coding stuff. So first I need to load the data set. I need to load the test data set. Let's find the code here. There's no point in writing it from the beginning again. Yeah, so this is the image. This is the code that we used to load before, and we use this code again. Actually, I think I can do. Hold on. I think there's something I can do. Flow from directory. So that was, if we go to sequential, or is it in models? I think it's in sequential. Let's go to hold on. So here we have data gen dot flow from directory, and that's from image data generator, and image data generator is under it's kind of hard to praise processing image data generator. That's what I was looking for. So if you go to the image data generator, it has flow from directory. So this is the directory, right? I wanted to see, can we do batch size is equal to 32? Okay. So this is automatically inferred. So this is if I use image augmentation. Okay, so flow from data frame. Okay, well, let's start coding and kind of let's see. So our training, our test directory is this right here. Is we change this to test, and same thing, class mode, batch size, we just leave it, and we'll call this test generator. Oh, there's something else I need to do. Basically, resizing the pixels, resizing the images. Then make sure that's the right syntax. Image data generator. Okay, yeah, that's the right syntax. Okay, control save, and then this is our test directory, test gen, flow from directory validation, and then this is test directory, target size. All right, let's go ahead and run this cell. So the so this test gen has 8,000 images and 15 different categories. So that's good. That's what we expect. So how do I load this test gen? How do I load this with multiple categories? So how do I load? Because if you go to TensorFlow dot predict, where is that? What's the difference between predict and predict generator? That's a good question. Let's find out. Generate predictions for the input samples from a data generator. The generator should return the same kind of data as accepted by predict on batch. Generator yielding batches of input samples on instance of so predict on batch. Okay, so I need to find. Okay, so there's so many different predictions you could use. I need to know the difference. Returns predictions of a single batch of samples. It okay. Computation is done in batches. Okay, generate output prediction for the input samples. Input samples, it could be a data set. So what's the difference between predict and predict generator? I really don't see much of a difference between them. You have the generator. Let's just use predict generator. Why not? Right? Okay, so alright. But I don't want to load the whole 8,000 images. Do you get what I mean? I only want to load like a few images. I don't want a prediction on all 8,000 images. I feel like that's going to take a long time. So, but let me go ahead and just run it. That doesn't look right. Model something, TensorFlow.model. Predict generator. This doesn't even, hold on. TensorFlow.keras.model.predict. Okay. Da, da, da. I think it's yeah, so I think is TensorFlow.keras.model.predict generator. That looks about right. Oh, duh. Cause I was wondering, like, how do I tell it to use my fruit model to do the prediction? Oh my goodness, my brain is dead. Fruit model dot predict generator, and then in parentheses we have. You know what? Why am I even doing this manually? Here we go. So I'm guessing the generator is going to be test gen, I guess. I'm going to go ahead and execute this. Then I'm going to go ahead and find out how to. So I'm trying to find out how to only load a subset of the images from each category, right? Each category is equal to the data set has 15 different categories. Okay, so the data set has 15 different categories, right? And 15 different categories. So load a subset of image from each category. I have an idea. How about I break up? If I run this, I feel like it's going to take forever. History objects has no attribute. Predict generator. Fruit model. Hold on. Oh, this makes a lot more sense now. This makes a lot more sense. Let's go back up here. This makes so much more sense. So this fruit model here is just storing the history. Okay, so the live stream is buffering, so I don't know if what's happening. But this right here is just storing the history. But for me to actually do any prediction, I have to do model dot predict. That makes sense. I think this should work. So yeah, this is taking forever. This is going to take forever, I assume so. So I need to figure out, okay, if I want to predict just Apple images, right? How do I do that? How do I extract that? I have an idea. This is going to sound crazy, but I have an idea that might work. So I could do something like, so I could be something like the Apple directory, right, is equal to it's equal to this slash Apple. Okay, and then I could use Apple gen is equal to, so I could hold on, Apple directory. I could do the Apple data gen is equal to this right here. Instead of using, hold on, dot flow from directory, hold on, flow from data frame. So I could use dot flow. Okay, let's see what dot flow does. Text, data, and label arrays generate batches of augmented data. Input data, numpy array or rank for or a tuple. If tuple, the first element should contain the images and the second element contain, okay. Y is the labels. Oh. Okay. So, well, this didn't take as long as I thought it would. Well, the only problem now is that I really can't interpret this data or what it means. Let's go back to model right here. And whew. Mm, true. Yeah. Let me finish this first. So oh, somebody said Michael Franco says they like my work and Lambda review. Thank you very much. That means a lot to me. I try my best. Okay, let's see. So if we just do flow, it's asking for an input data. If we flow from data frame, uh, takes the data frame and the path to a directory. So let's try flow from data frame, because like this is just the entire 8,000 images belonging to the 15 different classes. It's gonna be hard to read this. I just want to give it, let's say, 10 images of an apple and see if it can predict it or something like that. So the apple directory, this is the location where the apple directory is in the test files. So if we do something similar to this here, actually, but instead of, oh man, I screwed up. This should be this should be test data gen. Oh my goodness, I screwed up really bad. I made a typo. Uh, I mean, and to give me the exact same result to, but I just want to clarify that the validation and test data gen, the data gen is just this rescaling the images. So rename this to Apple, and instead of flow from direct, we'll just do flow from data set, right? No, flow from data frame, and then we'll just give it the Apple. And let's execute this code and see what happens. All right, image data generator has no attribute flow from frame. Oh, data frame, not frame. Ooh, we got a big error. String objects has no attribute copy. All right, let's see. Class mode. Actually, this is not right. It doesn't have a class mode. Right? Let's say class mode equal to categorical. Takes the data frame and the path to a directory and generates batches of augmented / normalized data. Let's just do flow and see what happens. Alright. Flow got an expected keyword target size. Why is that an unexpected keyword? Mm, 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 mm. I have a different idea of how this could work. I'm probably going to scrape all of that. Let's just do model.predict. Okay, let's just use model.predict. Where is that? Model.predict. Um, so model.predict. You know what? I have another crazy idea. Let's just give it the location of one image. So if we go back here and go back to the test file, and let's just go into Apple, and let's select image, right? And let's copy the path of that, and let's just call this single apple is equal to okay, so this is just a single apple, so let's tell it to predict this single apple and see what happened. Okay, it's throwing an error. String object has no attribute shape. Okay. Image equals okay. Um let's try something else. Let's try something else. So let's call this image is equal to image dot load image. Okay. And okay, so if we go back to the documentation, Keras processing image. If we go to the Keras pre-processing load image. Okay, so path to image file. Okay, so path is the path to image file. Grayscale, color mode, a pure image instance. It raises, okay, it was a pure image instance. Okay, so load image, and then the path containing the image, right? So this is the path of the image I want to predict. So basically, I'm struggling on the proper way to load an image for prediction. Okay, and then batch, and then we have to define the target size, and the target size is 150 by 150, right? Okay, and then image to array. So let's go back to the image here. Image to array. Converts a pure image instance into a numpy array. So it's going to convert to the image that will bring in into a numpy array. Okay. All right, let's do that. So let's call this just array is equal to image dot image to array, and this will be image. And if you go back up here, we imported image. So that's where the image is coming from. Keras image preprocessing function. So first we import the image using this line of code. Let's go ahead and run this code. Okay, name target size is not defined. Okay, so this code is working so far. So we imported the image, and then we turned the image into an array. Okay, that makes sense. Eventually we can put this in a for loop with different images. So but first I have to make it work with a single image, so I would know what what I'm doing. So we have the single image, then we've turned that image into an array, and then give me a second here to think about something. Okay, so we could do x is equal to, oh, I need to import numpy if I want to use this. Import numpy as np. We could do np.expand dims and x comma axis equal to 0. So let's go to np.expand dims and see what it means. So I guess my internet stopped working, which is fun. My internet stopped working. That's clever. Just perfect timing. All right. Okay. We could do print img just to see what it looks like. Okay. That's just an image stored in memory. And now let's print an array. Okay, so this is the array of the image. So this actually goes from 0 to 255, and this is definitely not rescaled. Okay. So basically, this took the image that is loaded, and turn it into an array. And now let's print x and see what it looks like. Kind of looks a little bit different. So if we print, that's x, and let's print array, so I kind of inspect the difference. So basically, just the image, just the array of the image, just the numbers that represent the image is a list. So this is list 1, list 2, right? List of list. Okay. And but then this one is kind of similar, but it's like list of list. So they are very similar, but different structure. Okay, let's keep going here. I don't need this. Okay. And one thing we can do now is, okay, we could be like, okay, so let's google, so np dot vstack. Stack arrays in sequence vertically. Concatenation along the first axis after 1G arrays of shape. Okay. So we could do image. No, we could be like I don't know, image is equal to np dot v stack parenthesis x. Okay, and let's go ahead and print this and see what we get. Okay, it's not that much different than what it looks like before with just the x. And now let's do model.predict v image. How about that? Let's shift enter and see. Okay, so oh my gosh, this makes so much sense right now. Oh, this is one of those aha moments. Oh my gosh, see? Oh my goodness, this I love coding. I love those aha moments. Like, this is it. This is the moment we've been waiting for. So remember, this is the image of an apple, right? So our model that predicted that this image is an apple. That's why I gave this a 1 and gave everything else a 0. Oh my gosh, like I feel like a genius right now. I feel like yes. Oh my goodness. Okay, nice. Beginning to make sense. Oh man. Oh. Okay, this is beginning to make sense now. Um oh yes, this is exciting. Oh, I have an idea. Oh, this is exciting. Let's put this in a for loop. Okay, let's put this in a for loop so that we'll just give it the name of images, and then to give us like a list like this and be like, hey, this image is this image is this. Oh, this is so exciting. Our prediction is right. Oh, let's try a different image. I've heard that bananas are difficult to predict. So let's see if it can correctly predict a banana, right? So let's find the image of a banana. So this banana is number 2. So um I'm going to put this in a function here in a little bit. I am so stinking proud of me right now. Like I'm not even kidding. Like this is exciting stuff. This is world class exciting. You know, like all right. So if this model can correctly predict a banana, then the number 2 spot should be a 1 instead of number 1. So this should be 1 and everything else should be 0. Okay? Fingers crossed, fingers crossed. Let's run this. Yes! 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 Oh my gosh! It works! Yes! It works! It works! It works! It works! Oh man. Oh. Oh man, this makes me so happy right now. Like, man, let me know what you guys think in the comment section. Let me know what you think in the comment section. It works. Oh man, this is a very happy moment for me. Like I built a model that freaking works, y'all. Oh man, this is an exciting moment. I mean, I have to go back and I have to go back and clean up my code, especially the ones that doesn't work. I have to go back and clean it up later. These ones that didn't work, I have to go back and clean other stuff. But let's put this in a for loop. Let's put this in a function or a for loop or something. To make it easier. To repeat this, I want to make it so that I will give it a location that has multiple images, and it to be able to predict it. You know, that's kind of the goal. So let's write a function that will do that. Okay, so let's we are going to write our function. Let's oh man, this is exciting. Really, really exciting. Like oh, I'm just excited. Like this just made my day. Like honestly, like I'm super duper excited. Let's just create let's go in here, right? Why not? Fruit project, and let's just I'm going to call this testing images. And in here I'm going to have one of each kind of fruit. Okay, so I'm going to apple, Control C, Control V, and I'm going to rename everything. So I'm so excited right now. So in order to load the images, we have to convert it from an image into numbers, which makes sense because computers can't really see images. What they see is numbers, you know? What computers see is numbers, and not actual images the way we see it. So let me go ahead and create a folder that has each of the different images, and I'm going to try to up, upload all images at the same time and kind of see the classification. This will make a little bit more sense once we start building. So basically taking the code that we know works and putting it into a function. Uh, just bear with me here, as I create my test file, like I like to call it. If you guys are watching, just let me know in the comment section below or in the chat room. I'd like to know what you think. Do you like watching me struggle through this code and then finally getting it? Or do you just feel sad for me when I've struggled through the code? So this is, I'm just going to oh man, this makes me so happy right now. Like, I'm not even kidding. Okay. Pomegranate and tomatoes. Okay. And now let's rename this. Rename. Let's call this guava. Uh, I'm going to rename this because I'll try to get it to print out the names. So we'll see if that works, right? After tonight, my next challenge is kind of figuring out how to deploy this. How do I deploy this, on using something like a web page where people can upload their own images and see if it can predict what it is. I'm just so excited right now. Like, this worked. Like, this makes me so happy right now. Parsimon, parsimon, pitaya, plum, pomegranate, is that how you spell pomegranate? It doesn't matter. Tomatoes, tomatoes. I think they spelled it wrong before. Okay. Oh man, this makes me so happy. I know I shouldn't like. This is an exciting moment for me. An exciting moment. Let's see here. Okay, so. Mm, okay. I need to copy path of this. And okay, let me go here and let me see if this can be done. You know, if I I'll call this not single. I'll call this something like, I don't know. This is just me code testing before I put it in a function. I like to write my code individually and test it out before I put it in a function. So let me call this image dr. Okay. So how do I load the images in the directory? Okay. Ooh, this is where a for loop comes in. So I can be like, for fn for fruits in image directly. So basically I'm saying for every fruit in this image directly, I want you to do this. And let's tab this once, and I'm going to change this to fruits. Okay. All right. Classes, let's call it image classification is equal to this, and then I want you to print image classification. If this works, then I'll find a way to make it print the image name. That's another challenge I'm going to have to tackle. Yeah. That's another challenge I'm going to have to tackle. How do I get it to print the names of that's actually a good question. Let's go ahead and run this first and see. Alright, what's the error message say? No such file or directly see. Fruits. No such file or directory C, and this is coming from image is equal to file not found. Okay, let's do the path is equal to fruits, and let's call this path. Okay, file not found. Okay, let me see, what am I doing wrong here? I see. I see what the problem is. It's not let's see, how do we extract? So the name dot, for example. Okay, so this is a string. So how do we extract the let's see, let's try something. Control Z. Okay, os dot list image. Okay, all right. So we could say something like so we could say something like, I don't know, banana is equal to this, right? And location 1, and then do banana. So that's banana.png. OS, I could do os.path.join. I could do os.path.join, and in parentheses, let's join image directory and banana, and let's see what happens. Boom, boom, yes, yes, see, yes. Okay. All right, so this is kind of the syntax we have to use. Okay, this is the syntax we have to use to create a yeah, this is the syntax we have to use to tell the computer, to tell this function the location of the file. Okay, so for every fruit in this, path equal to path equal to I need to think about how to best implement this. Let's try this here and see if this works, and then print P. Okay, that doesn't look good. Now I see what the problem is. That doesn't look good. As I joined us. I see. That doesn't look very good. So, oh, I have a better idea. I have a better idea. I got a better idea. I've 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 got a better idea. This is a better idea. So for everything in my list, what? Right? Because remember, this my list is this list of fruits, right? And we want this list of fruits to be joined with the image directory path. So it's already, oh, it's 10 p.m. Okay, sounds like it's 11 p.m. That was my time limit. I don't want to live stream past 11 p.m. Okay. So we wanted to join image directly with R. Okay, let's run this code and see. Oh snap! That's what I'm talking about. Oh yeah. I've got a better idea. I've got a better idea. Told you so. Okay. This code works. Let's go ahead and copy it and go back to the function we had earlier. Alright, so if we go back here, let's just go ahead and paste this code here and copy as we needed. So for fruits, and so my list is equal to os.list directory of this image this for fruit, which is R, in my list, and I'm going to change this to my list. Let's call this image list, right? For clarification. Okay, so for fruits in image list, okay, the path is equal to this, but R is going to be fruits. So for every fruit in this list, I want you to join this home directory with the name of the fruit, and then I want so that will give you the location of that particular fruit, and then I want you to load that image right here, and then turn that image into an array, into numbers, and then run those numbers through our model, and then I want you to print your prediction. Good. All right, so give me a second to delete stuff I don't need, which is basically this. All right, let's go ahead and run this. Okay, let's see how our model did. So let's copy this. Oh, I wanted to print. I have a better idea. Let's just go ahead and do this in a different cell for the sake of just clarification. I don't need this anymore. Oh yeah, actually this is it right here. So basically the first one should be a banana, right? And let's go back to test, for example. So the first fruit on the list is a banana, and banana was the second one in our prediction model, so that's right. Second fruit here is carambola, and carambola was the third one, so that's right. Third fruit here is a guava, and guava was the fourth one, so prediction is right. Fourth fruit here is a kiwi, and kiwi is in position number 5. So 1, 2, 3, 4, 5. Okay, so 1, 2, 1, 2, 3, 4, 5. So this one, the prediction is wrong. So it's got the kiwi prediction wrong. It predicted the kiwi to be let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it predicted the kiwi to be a peach. And then let's say the mango here was number. This is listed in alphabetical order, so that's why it's kind of confusing. So mango here, you have mango. Wait. Why is tomatoes, red apples? Oh, I messed this up by saying red apples. Hold on. Give me a second to fix this. I was like, why is this out of order? Let me rename this. So everything go back into order, because I'm like, this doesn't make sense. We have to rerun everything now, which is fine. Now we start with apples. Now the predictions should match. So the first one should be apple. Second one should be a banana. And then third one should be carambola. Third one should be a guava, right? Guava. And the fourth one should be kiwi. But it's predicted the kiwi to be peach, like we saw earlier. The fourth one should be, and then we should have muskmelon here. But again, it's predicted the muskmelon to be a peach. That's interesting. And then the fifth one to be orange, correctly. So again, the orange prediction is wrong. And then, so some of these predictions are like not right. So the last one here should be right here. So it predicted the tomatoes to be pomegranate. Yikes. So our model is accurate for some fruits, but it's not for others. But we need to try many different fruits for us to really find out like how our prediction is doing overall. I'm going to one last thing before I end today's live stream is figuring out how to attach the name to it. So the model is accurate for some predictions, but it's not accurate for some predictions. But this is the first set of fruits I've tried. So I don't know yet. Actually, I think I want to put this in a function. Let's put this in a function so that in the future it will be easier to just upload a fruit, like just find a new fruit and be able to use it. So let's put this in a function real quick before we move on. So definition fruits prediction. And whenever you are predicting a new fruit, you need to give it the path, right? Let me see, how do I want to do this? So yeah, you just need to give it the path where the image is located. And let's try out this function. Okay, let's say uh okay. This is not complete. Okay, so you need to provide the image directory. Okay, so I want to make it in such a way that you just provide the folder that contains the image. So it doesn't matter if it's a single image or multiple images, it will this should be able to work. So all you have to do is provide this information. So let's go ahead and delete this from here. So from here you have the fruit prediction image directory, then you have the image list. Okay, and then for every fruit in this, so even if it's a single image in this directory, this should work. Let's go ahead and run this. All right, and let's call our function and make sure it works. All right. Yep, our function works as expected. Cool. Now that we have this in a function, we can keep working. And I'm going to add a comment later. Like when I come back to this code, I have to clean it up. I have to take my models and put them in functions. I have to add comments and stuff like that. So yeah, there's a lot of work to be done here. Let's see. Okay, so now the next challenge is figuring out how to attach the name. How to attach the names to it. So mm, 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 mm. So we could say something like let's test it out over here. Mm, well, plus fruits in this case. Oh, the wrong place. This is not where I want to test this. I want to test it here. I was like, why is this not working? I don't know if this will work. Okay. Mm. Oh, okay. I see you. I see you. I see you. I see you. Okay, so this is apple, banana. This is supposed to be carambola. Supposed to be a guava, and guava is number fourth position. This is supposed to be kiwi, which is in the fifth position, but the prediction is wrong. So um yeah, I think I'm just going to leave it at this so far. How about mm, yeah, I'm going to leave it like this. This is kind of like the best way to represent the um mm, could I be like, okay, so well, with this allows us to see quite easily that, so we know this is the correct prediction, and then we know that this is a wrong prediction. If I wanted to do something where it would just print 1 and ignore all the zeros, but if we did that, we wouldn't know that kiwi was predicted wrong, or mango was predicted right, so forth and so on. So but I think I'm going to leave it like this. This looks good to me. Let me go ahead and run this. So and plum uh was predicted to be a banana. Yikes. Pomegranate predicted wrong. Tomatoes predicted wrong. Pitaya predicted wrong. Actually, was this supposed to be? So a lot of this was predicted wrong, But then hmm, mm, how can I improve this? How can I give it lots and lots of images? Uh, yeah, but this is basically how far I'm going to take this for now. Um, this is how far I'm going to take this. So now my next challenge is figuring out how to deploy this. So like, how do you deploy it, really, so that other people can upload their image, and then it will be able to give them a prediction of what it is. Oh, one last thing before I end this live stream. I want to see if my saved models are working. So I want to make sure my saved models can do this. All right, so let's go ahead and load the saved model. Where did we load that saved model earlier? So many red So many error messages. Okay, so let's go ahead and load one of the saved models and just verify that we can use it. Okay, shift enter, and now let's try to, so if you go to this saved model thing, so to re-evaluate the model, we do the loss and the accuracy is equal to model.evaluate test images, test labels, and variables equal to 2. Okay, if we go back to TensorFlow documentation here and let's look at some things. Models, load model. So no, that's not what I'm looking for. Model.evaluate. Uh, model.evaluate. Where would that be? Model and evaluate. So the x, the y returns the loss values and metrics values for the model in test mode. Okay. Does it have a target size syntax? No. What's this? Evaluate generator. Let's just use model.evaluate and so model.evaluate the test images, variables equal to 2. Let's go ahead and copy this code. So this is new, Control C. Okay, so just going to remove this and then replace test images with the directory that has our images, right? Can I get an accuracy score for a prediction? Anyway, that's just an idea that came into my head. Let me go ahead and try something real quick. So these are the predictions, right? How about I set it equal to something? I want to see, does the prediction right here, does it have an accuracy score and a loss score? That's so we could get the accuracy of it, of the prediction. Could we do that? I know I keep going back and forth, but give me a second. I'll get back to what I was doing before. I don't know what that is. Let's go back to predict. So this one returns a history object. But the fit model and the fit generator returns a history object. But predict just returns it returns numpy array of predictions. It just returns an array of predictions. It doesn't actually tell you the prediction score, how accurate it is. So let me Google that real quick. So TensorFlow prediction score. It raises properties, method, now okay, that was just an idea that popped into my head. I wanted to. So the model that predict doesn't have a history object. The history object is what allows it to for us to do history for us to do something like the history object is what contains the loss function and the accuracy function scores, but the predict function doesn't have it. Only the fit and fit generator has it. Okay, that's good to know. Let's get back to what we are doing. So this is just me verifying that the model that I saved can perform this task. This task right here. So bear with me for a second. So this is me loading the model, and then I want to get the loss and accuracy function from the image directory. Okay, let's go ahead and run this and kind of see. All right. String object has no attribute shape. All right, so test images. Let's pass in okay, I think I know what the problem is. Let's this. I know this looks like a complete mess, but I'm going to clean it up later. So let's call this text directory. So this is where the test directory is, and let's change this into test, and let's run this again. Test. All right, let's see what the problem is. String object has no attribute shape. But that's not a string object though. Huh. Mm. Mm, 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 mm. So, okay. Evaluate test images and test labels. But I don't have the test. Mm. Okay. I have an idea. Um. Whew. Okay, so test images. Let's call this test images. Mm. Test images. And let's go back here and to so these are my testing image directory. And let's say test labels is equal to os.list directory for test images. Test images. Yeah. Okay. All right. String object has no attribute shape. Okay. Oh, it's a string, and while it should be a numpy array. Duh. Oh man. Oh, okay. That makes sense. So I'm basically feeding it a string instead of a numpy array. Oh man. Oh man. My life. This makes so much more sense. Okay. Uh Yikes. Okay, so I need to feed it this. Okay, so ba, 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 ba. Let me go ahead and copy this whole thing and make a few changes before. So that should be. Oh man. Okay, that makes sense. So this it's giving this error because it's expecting a numpy array, and I'm giving it a string. So the images is a numpy array. Like I keep forgetting that, and like the computer can't actually see an image. What they see is numbers, you know, and they translate that numbers into images. So okay, so all right, let's put this here. So image, so v image is what I need to be feeding this. Okay, so I'm going to write this just a little bit. So basically, test images. So this right here needs to be uh okay, so basically so basically what I'm doing right here is just taking everything that's in here and putting it in a list. Okay? And then because this is expecting an array, and this code right here takes every image inside this thing and turns it into an array, and turns it into numbers, right? So I really don't need this. Well, I don't think I do. Okay. Yeah. Okay. Can I use a return statement inside a for loop? Huh. So that Yeah, I think you can have a return statement inside a for loop. So I'm going to try this in a different code cell before I execute it. I need to clean up this code so much. Like I have so much cleaning to do. Return outside function. Great. Um um that doesn't look very good. Uh okay, so basically what I did here is like I took all these images and appended it into the test images. I took all this array and appended it into this. Huh. Let me comment this out and test out one more line of code. So, and just do and see what the output is going to look like. Yeah, that doesn't look good. So the way I did it the first time is the right way to do it. Okay. I mean, I knew that, but I just have to. I like to try out different theories. And I should be in bed right now. It's almost 8 o'clock. It's almost 11 p.m. at night. It's bad habit to be coding way into the night, right? Don't do what I do. Do what I say. Go to bed early, y'all. So this final test images now has this array. Now let's feed that into this. So um yeah, I'm just gonna comment all of this out. Now let's try this and see. What the heck? When checking input, expected conversion to the input to have 4 dimension, but garret with 150 153. What the heck? Mm, Okay. I'm trying to see the best way to convert the images into an array and then use it. Hmm. But I just use X. So it's just expecting an array. So how about array? What if array is what I'm looking for? Because for some reason this is not uh let's go back to here and see. Error when checking expected 150 by 3. It was expecting a convolutional 2D input to have 4 dimensions but got array with the shape 150 by 3. Huh. Okay. So how about we try at X? Okay. And let's do X here. String object has no attribute shape. Of course. One fifty by 3. I think I know what I need to do. Um yeah, I think I know what I need to do. I know what I need to do. Give me a second here. Uh uh okay. I think this is the information is asking for. But we're about to find out if I'm right or not. Mm 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 mm. Image. So now let's change this to test gen, and let's see what happens. it's working. Yeah, I suspected this would take a long time, which is why I didn't want to load the whole image. Okay, so okay. So I learned something new. The right way. So when you're doing a model.evaluate, your whatever you put in here needs to come from the directory. So sometimes the only way you learn something is by breaking stuff. Seriously. So I don't know how long this is going to take. But if this works, then this kind of concludes everything for today. I'll go ahead and delete this. I don't need this. And actually, I'm going to uh, I'm also going to load this saved file just to verify that it works. So basically, I don't know how long this is going to take, but even at that, I shouldn't have used the images in the test directory because that's what I would be using to do model.predict. So it's not throwing an error yet, so I think it's safe for me to. Okay, it's restored model accuracy is 97.99. Okay, so this makes me very happy. This means that the model was successfully saved, which means in the future I could easily reuse this model again. That's good. Now let's do the same thing here for this saved model. So I saved the model in two different places, one in this directory and one directory right here. So let's go ahead and run this cell, and this should have been my validation, honestly, not my test. I messed up on this one. This should have been validation. There's absolutely no reason for me to touch my um, test data set because that test data set is just that, for test. So let's change this back to val. All right. And now I'm testing if to see if this saved model is working as expected. And of course, this is going to take some time to run. And once this is done, I'm going to do new. I'm going to do this function all over again. I'm going to be doing this function all over again, but this time instead of using model.predict, I'll be using the new fruit model for the prediction. And this is just me verifying that the model is saved and the model can be used for predictions. So yeah. And then after that, I'm going to call this function, and let's do fruits. Yeah. The image directory, the directory that has the image is let me find it. There. So once I run this prediction function again with the restored model, then I'm going to verify that the model that I saved is working correctly, and I can also use it for prediction. This means in the future, when I want to redo, when I want to do this, when I want to use this again. Okay, so this works. So we got 98% accuracy. All right, so let's get and run this and run this. All right, our model works as expected. So this is good stuff. So I think that pretty much concludes it. My next objective is kind of figuring out how to. My next objective is cleaning up the code, because like this project was a learning process for me. So I'm going to go through and clean up the code and add a lot of comments on it, and then after that, I have to figure out how to deploy the model. That's kind of my next objective, is to maybe take online courses and figure out how to deploy the model. I mean, I know how to save the model, but how do I deploy it online in such a way that somebody can just upload an image and then it to run the prediction test for them. But that's just kind of like the next level kind of stuff. That's kind of my next objective, figuring out how to upload the model online. But anyway, that's it for this. I'm going to clean up the code, and probably I'm going to clean up the code, and I'm definitely going to write a blog post about it. So if you go to my website, and then you go to portfolio, you'll be able to see my portfolio, right? And it looks like my image is not working. That's really sad. Okay, I don't know what's going on. So you'll be able to see my portfolio. This is the first portfolio I ever did. This is my most recent portfolio. So I'm going to take this project and I'm going to add it to my portfolio. I'm going to write a blog post about it and add it to my portfolio. And if I figure out how to make this model available online, then I will also live stream the process of doing that. So otherwise, this is kind of like the end of it. I've achieved what I wanted to do. I wanted to like build a model that can give me predictions for like 15 different fruits. So yeah, I'm excited. I'm really happy I did this, and I'm surprised I was able to do it in 2 days too. So I'm looking forward to doing more complex, bigger machine learning models in the future. Thank you all so much for watching. Just ask me questions below and comment, and I'll respond as necessary. Otherwise, bye.